This instructional video is about solving and graphing inequalities. That is an OR condition. Last time we talked about was an AND condition. That's when you have an inequality where the x is going to be less than or equal to something and greater than something. Less than some number and greater than some number. That's what we did last time. This time we're going to talk about OR. OR means you could either go that way to the right from a given number or to the left from a given number. So that situation is the OR. You cannot be in one place at one time. You could either be here or there. And that's what this inequality deals with. These are the lines that are diverging. So to solve this, we're going to solve for x by subtracting 7 to both sides of the inequality. So on the left we have 2x is less than, well, you have 3, take away the 7. If you have $3 in the bank and you take out $7, you owe the bank $4. Negative 4 balance. Now to solve for x, you divide both sides by 2. So x is less than negative 2. To solve for this inequality, we're going to subtract the 5 to both sides of the inequality here. So on the left we have 5x is greater than or equal to 10 minus 5 is 5. To solve for x, we divide both sides by 5. So x is in fact greater than or equal to 1. X is a less than negative 2. X is greater than or equal to 1. So let's draw the number line. The bigger number is 1, so that goes on the right side of the number line. And this is going to be x is greater than or equal to. Greater than or equal to 1. And greater than means to shade it to the right. And this one is x is less than negative 2. Negative 2, but not equal to. We're talking about numbers that are less than negative 2, but not equal to. So everything to the left. And there's your answer. Now why don't you try the second one. Okay, so same thing as before. Now we're going to subtract both sides by 8. So you have on the left 3x is greater than 17 minus 8. That's going to be 9. Now to solve for x, we divide both sides by 3. So 3 is reduced, becoming 1x, or simply x, is greater than 9 divided by 3 is 3. Something that is going to be greater than 3. Here, we're going to subtract 5 to both sides of the inequality, giving you 2x on the left is less than or equal to 7 minus 5 is of course 2. To solve for x, we divide both sides by the coefficient 2. So 2 and 2 simplifies to become 1x, or simply x, is less than or equal to 1. So we're talking about two numbers. Now be careful here. I always ask the students, of the two numbers, which one's bigger? Is it the 3 or the 1? 3 is bigger, so it goes on the right side of the number line. And x is greater than, but not equal to. There is no equal to. Just greater than. So greater than 3, but not equal to, is going to be to the right. Now the smaller number 1 is on the left. Again, x is less than or equal to. So since it's equal to, 1 is part of the solution. And less than means like 0, negative 1, negative 2, which is all on the left side of 1. Now since our initial answer here was x is greater than 3 and x is less than or equal to 1, but our number line shows the bigger numbers on the right. So for those perfectionists, we should write the inequality to match our number line. So x is less than or equal to 1, or x is greater than 3, but not equal to. No. So that becomes our final solution. There you have it.